It's a, you're really not. It's a review, yes. But here's the good news. Okay, the review's over and your test is over. Okay, so it's not like a huge test over a million things. It's just really over one little mini unit. Yes? Great question. It's going to be while you're on the band trip. It's Thursday, Friday. But it's okay. We'll just do it when you get back. Or if you want to take it before you leave, then just come by tomorrow and you can take it. Okay. All right. So take a look at your review. Goal is we're going to go through it. We're going to do half of it together. You'll do the second half. So look at number 2. Okay. Number 2. So it says initial point 1, -3, terminal point -812. So I want you to set up just like a little mini graph here. Where would 1, -3 be? How would I graph that as my start point? Okay, so I would go to the right. 1, thank you, and then down 3. She's here, I'll send her, thank you. So it'd be 1, 1, 2, 3. That would be 1, -3. Okay, then where is my other point gonna go if it's -812? How am I gonna graph it? I'm gonna start at the center and go to the left 8. So 1, 2, 3, 4, 5, 6, 7, 8, and then up 12. We'll just say 12 is way up because I don't want to actually count it out. Okay, well then my vector is going to go from the start to the end. Remember, it's an arrow. So you would just be like, bloop. Okay, and then remember that whenever it says to write a component vector, okay, it's just talking about the X change and then the Y change. So what I'm going to do is I'm going to trace this across this way and then up. And then I'm going to count. Okay. Now, the other thing is on your actual test, I'm going to give you a grid so that you don't have to make this little shady graph. Jacob, we ready? Okay. But since you don't have one, I'm going to show you a really easy way to count this out. How many did I go this way? 1. And how many did I go this way? 8. Then how far is that total distance, even if I didn't draw the actual box? 9. And then also, which way did I go 9? Did I go 9 to the right or 9 to the left? So it'd be -9. Okay, then I want to count how far I have up and down. Well, remember, I can see I went down 3 here, and then I went up 12 here. Then how long is that total side? Up 3 and then up 12 more would be 15. Okay. But on your actual test, you'll have a grid so that if you want to plot the real points, you could do that. Okay. All right. Next question. It says find the magnitude of the vector. Okay. Remember that magnitude is a squared plus b squared. And take the square root. Okay. Remember that magnitude is also how long the arrow is. Okay. So if you were looking for the length of the arrow, that's what magnitude means. Do we need the negative for the 9? Do you remember? No, you don't. So I'm just going to do 9 squared plus 15 squared, and then I'll take that. Okay. And then hopefully you grabbed a calculator. So 9 squared plus 15 squared, what do we get? I got 306. Okay, now there are 2 ways you have to be able to write this for your test. The first one would be the exact value. You would tell me the square root of 306. Okay, but then if it asks you to round it, then you would actually take the square root in your calculator, square root of 306, and you would get 17.5. Okay, so this is the exact value. This is the rounded value. And it'll tell you on your test which one you're doing, but I just want to make sure you know the difference. Exact means go ahead and just give me what the square root is of. And then rounded would be type it in and see what it is. Okay. Second thing you need to know how to do, actually third thing, so you need to know how to graph them. You need to know how to do magnitude. The next thing is how to find the reference angle and then the direction. So write down for reference angle, you're going to do tan theta equals y over x. Remember, again, nobody cares about the negative. So for example, on this y of 15 over x of -9, I'm just going to put 15 over. So I'll do tan theta equals my y is a 15 over my x is a negative. So then from there, do we remember how to cancel out tan using the calculator? You remember? Well, they're too quiet today. Okay, you do the inverse. Okay, if you remember how to do the inverse, you're going to do second tan. So like that. Okay, and then remember the tan and the inverse tan cross out, and then you'll know exactly how big your angle is. So inverse tan 15 over 9, I get 59 degrees. Okay. Now remember, that's your reference angle. There's one last thing you have to be able to find, and it's the direction. Remember that the direction of a vector depends on which quadrant it's in. So if I were to go back and think about my vector, V was -9, 15. What quadrant would that end up in if I were to graph it? 1, 2, 3, or 4 if I were to graph this. I would go to the left 9, and then I would go up 15. So left and up, I'd be here, yeah? What quadrant is that? Quadrant 2, thank you. And then do we remember that each quadrant has its own formula? So let me just remind you what the formulas are for that. If you're in quadrant 1, whatever your theta is, that's already your answer. Okay, but if you're in quadrant 2, it's going to be 180 minus the theta. What about if I'm in quadrant 3 down here? Then what do I change? Instead of 180 minus the theta, it would be, yeah, plus the theta. And then for your last quadrant, it would be 360 minus the theta. Okay, so that's your chart. If you're looking for, I'm going to label it direction. Okay, so I know my theta is 59 degrees, but then I have to think about like, okay, well, which quadrant am I in? So I know what to do with the 59. And then I see, oh, I was in quadrant 2, then I'm picking this formula right here. So I do 180 minus 59 in the calculator. And I get 121. 180 minus 59 equals 121. Okay, and remember that's called the direction. So your reference angle is the theta, and then your direction is based on which way your vector. Overall, any questions about that? Okay, so you're going to do 1 and 3 on your own. Turn the page when you're ready. Next one that we're going to do is going to be number 7 or number 4. Okay, now look, they already gave you the vector right here. Question, I know y'all aren't very talkative today, but pretend that you want to be for this. How do I know which one of these is a vector? What gives it away? Look at the 3, 8, look at the 7, 2. Okay, very good. Vectors don't have parentheses, they have the little pointy bracket. Okay, so that tells me that that's the vector because of the parentheses. Okay, so I'm going to skip this for right now, and I'm going to go on to magnitude. Remember, magnitude is how long it is, which means that I'm going to do a squared plus b squared, and then take the square root. So I'm going to do 3 squared plus 8 squared. Then I'm going to take the square root. Type in 3 squared plus 8 squared in your calculator. I get 73. That's the exact value. And then if I want to round it, then I actually type in the square root and I see, oh, that's about 8.5. Okay, so remember, your test will ask you for both. That's what that's referring to. Okay, your exact value is with the square root still in it, and then your rounded values when you type it in. Okay, then after we find magnitude, we're going to find direction. Okay, remember that direction is tan theta equals y over x, which is going to be what with my 3 and my 8? Which one's going to go on top? Eight is the y, 3 is the x, and be 8 over 3. Okay, then from there, remember we talked about on the front page to actually solve for your theta, you're going to inverse tan on both sides. And then your tan and your inverse tan are going to cross out, and then you'll know exactly how big your theta is. Theta is the inverse tan of 8 over 3, okay, which is 69.4. So we'll just round that to 69 degrees. Now remember, that's your reference angle. Okay, this is not asking you though for the reference angle, it's asking you for the direction. So remember, if it's asking you for direction, you just check the quadrant. What quadrant would 3/8 fall in? If I started it from the origin. Quadrant 1, because I'd go 3 this way, and then 8 this way, and that would be my vector. So then look back at your page. If I'm in quadrant 1, what's the formula for direction? What do I do to the reference angle? Nothing. You keep it the same. Very good. So if I'm in quadrant 1, then theta is my answer. So that means that your direction and your reference angle are the same. So I'm going to put theta equals 69 because quadrant 4. Okay, that way if you look back on it, you'll know what that meant. Okay, last little part of this question that I skipped. Okay, it gave me the vector. It told me it was 3/8, but it's telling you it wants you to sketch it with the initial point 7, 2. So what that means is I want you to start the vector here and then graph it and see the terminal point is where does it end. That's what the question's asking you here. So set up a little grid for me. We're going to count to 7, 2. Your graph doesn't have to be perfect, but I would count 1, 2, 3, 4, 5, 6, 7, 8, 2. That's 7, 2. And then from that point, I'm going to graph vector 3. So I would say, okay, well, then what do I have to do? I have to count to the side 3, 1, 2, 3, and then up 8. 1, 2, 3, 4, 5, 6, 7, 8. There's my vector. And what the question is asking you is where does it end? So I started it at 7, 2. That's my starting point. And then I'm ending it up here. And then it's saying, what is this point that it ended at? Okay, so I want you to think about, for this dot, I'm already at 7. And then how many more did I count over? I already went over 7. How many more did I count over from here to here? 3. Then what's 7 plus 3? 10. Okay, then I had already gone up 2, and then I went up 8 more. So then how long is this side? 10 again. Okay. But I'm going to put for your test, use the graph paper. Yeah, I meant to put it on the packet. So I'll put use graph paper to count because it's a lot easier when you have your graph. Okay. All right, you're gonna do number 5 on your own. We're gonna do number 6. So go down to number 6 when you're ready. Number 6, you have a vector P, and you want to write down the new vector 3P. Okay, remember that 3P, all that means is you're going to multiply vector P by 3. So I'm going to put here, multiply P by 3. And then remember, when you multiply by 3, you have to multiply both of the coordinates, not just one of them. So if it was initially a 2 in the front, -7, but I'm going to times it by 3 now. Then what's the first coordinate now? 3 times 2 would be 6. And then what about 3 times -7 for the y coordinate? -20. Okay, so remember, when you're doing vector multiplication, you have to just make sure that you times it into both terms. Okay, then the steps are the same. They ask you for magnitude. That's a squared plus b squared, then take the square root. So it'd be 6 squared plus 21 squared, then take the square root. And then remember, you're going to write it 2 ways. First, as an exact value. So you do 6 squared plus 21 squared. I got 477. And then I'm going to actually type in the square root to get the decimal of that. So 477 square rooted is 21.8. Also remember, what feature is magnitude? Magnitude is the length of the vector, how long it is. Okay. So I'm going to label this again. The first number is the exact value. The second number is the rounded value. Okay, then after you find magnitude, you're going to be asked to find the reference angle, just like we did last week. So you're going to write down tan theta equals y over x. Okay, but in this case, my y is the 21 and my x is the 6. So I would do tan theta equals 21 over 6. Okay, and then I'm going to put a little star here. Don't need negatives. Okay, if there's a negative, it doesn't matter for tan, you can just leave it out. So then I'm going to do second tan here, 21 over 6, and I get 74 degrees. Okay, remember that 74 degrees is your reference angle. That's not always the same as your direction. How do I check if that is my direction? What do I have to look for? You have to check what quadrant you're in. That's exactly right. So then you would just go back to this and you would say, okay, well, 6, -21, where's that going to fall? I'm going to go forward 6, so we'll go here. And then I'm going to go down 21, that puts me here. So then what quadrant am I in if my vector would be down here? Quadrant 4, and then look back on your sheet. What's the formula for quadrant 4? Very good. It's 360 minus theta. So if I'm in quadrant 4, then I'm going to do 360 minus theta. And then remember, in this case, my theta is 74. So I do 360 minus 74 gives me 286. Okay. And then remember the difference. The first one is your reference angle. And the second one is your direction. Remember, the only place that those numbers are the same is if you're in quadrant 1. Okay? Okay, we're going to do a couple more examples in the next section, and then we're going to take a break, and you guys will be able to do the ones that we've skipped. Okay, so turn to the next page, and we're going to go through number 8 is your goal for the first half. Okay. So first thing we're going to do is rewrite your vectors. Okay, remember there are two ways for you to write vector P. Vector P is 2, -7. The other way that we talked about that you can write vectors is you just put an I with the first number and a J with the second. So for example, if it's 2, -7, I would make it 2I minus 7J. And then remember, those are the exact same vector. It's just a different form of writing. So where you're going to see that on your test is it'll be matching. It should be super easy. Okay, I goes with the first number, J goes with the second. Okay, so now look at your second vector. You can see it's 5, -4. Well, then if I have 5, -4, I'm going to put 5 with the I and -4 with the J. Okay, then we have one more left, 3, -2. That would be 3I minus 2J. So pretty straightforward on those. Shouldn't be really very tricky at all. You're just matching. Okay. All right. Next little section here. You should be able to add and subtract vectors. Remember, you can only add the X's with the X's and the Y's with the Y's. If there's multiplication, though, you should do that first. So, for example, let's say that you were doing letter E. I have P plus 2U. Well, then I'm going to write down P. P was 2, -7 plus 2U, and U was 5, -. And then remember, before you add the X's, you need to multiply that 2 into the inside first. So for example, my 5, -4, both of those numbers are going to get doubled. So what would that second vector be now? 2 times 5 is 10, and then 2 times -4 is -8. Okay, then from there, remember, you can only add the 2 X's together and the 2 Y's together. So for example, that means I can put the 2 and the 10 together. 2 and 10 gives me 12. And then I can add the -7 and the -8 together. Okay, you can use your calculator on that if you need to. -7 plus -8 gives me negative. Okay. All right, now look back at C. So E was a plus 2U, but C is a minus 2U. So let's just talk about what changes when you do that. Your P is still 2, -7 minus 2, and your U is still 5, -4. You're still going to times the 2 in, but you're going to take the negative with it. So it would be -2 times 5, and then -2 times 4. So if it's a subtraction, you bring that negative inside. So now, instead of 2 times 5 being 10, now it's going to be -10. And then -2 times -4, that's going to now be a +8. And then once you push the negative into the second vector, now it's just an addition problem. You work it out just like the other one. Okay, so once you brought this negative inside, it should just be a plus on the outside. Okay, and then from there, add the X's together, add the Y's together. What is 2 plus -10? You have a calculator? If you need it. Anyway. And then what about -7 plus 8 for the Y's? That would be 1. Okay. All right, last two we're doing together are F and G. It says describe the changes to P when it's cut in half. So this is P, this is half P. what change would you expect to see if you went from P, we'll say this is P, to only half P? Okay, there are two things. The question on this is a graphing question on your test. Okay, but think about if my number, let's say that this was 10.5, or we'll say 10.8. The only thing that would change when you cut it in half is that now instead of being 10.8, it would be 5.4. But graphically, your arrow will still point the exact same direction. The only thing that's going to change is how long it is. Okay, so if I go from this to this and I cut it in half, you're going to be pointing the exact same direction, but it's only half. Okay, so I'm going to put point same direction. But it's only half as long. Okay. So if you double a vector, if you half a vector, if you triple a vector, it's going to point the same way. The only thing that changes is how long. Okay, then last question we're doing right now, letter G. What about if I go from P to negative 3P? Well, the negative is going to make it not point the same direction anymore. It's going to make it point the opposite direction. So the negative is going to flip it to point the opposite direction. And then I'm going to put in parentheses below that because negative. And then what does the 3 do? If a half makes it half as long, then what will the 3 do? Make it it will make it 3 times as long. Come on, guys. You're killing me. 3 times as long. Okay. All right. So I know it's tempting, especially when everyone seems so sleepy, but let's get your review done. Okay, your review's a quiz, great. We're going to pause here. If you want to work ahead, you don't have to do 8 or 9. I cut that off your test. Okay, so once you get to here, then we're going to pick back up with the second half and we'll run through 2 of the last 3 questions and then you'll just finish it off. Okay, but you can do it. If any of your calculator numbers were coming out wrong, make sure you're in the right mode. So if you push the mode button right here, you should see that degree is highlighted. If degree is not highlighted, all your answers are going to come out as little tiny decimals. You don't want that. Okay? So make sure degree is highlighted.
Do you have a band?
Hang on one sec. You what? How'd it go? Okay, well, so we're taking a test on Thursday, or well, no, Friday. So we went through like this one, and then you go through these 2 are the same, and then we went through this one and this one, that one, and then these 2. So kind of like but you can just use mine. And then I also recorded it, so if you have all the I think this lunch is almost over. How about when it rains, then you can go and I'll send you. Okay? Yeah, take you lunch. Because if you go down there now, they'll send you back up in like 10 minutes. What did you need? I do. Not very many, but I might have a rubber band or 2. How many do you need? You need like a stack one? Okay, last little bit of this, And then you guys can just kind of finish. If you finish your review today, I can check it off and put it in the grade book, but if not, it's not actually due till you take your test. Okay, so look at number 10. Remember that any time that you have a vector and you know how long it is and you know the direction, you can break it down into a component vector. So the way that you would do that is you're going to do the length times the cosine of theta, and then the length times the sine of theta. Okay, and then remember that length and magnitude are the same. So if they tell you that A is 9, that's how long it is. And then the direction of 105, that's your theta. So if you have that info already, you can break the vector down into its two component parts. So you would do 9 times the cosine of 105. And then 9 times the sine of 105. Okay. Then again, that's your exact value. If you want the approximate value, all that you have to do is type it into the calculator. Okay. And so in the calculator, you would just type in just like this. Watch. 9 cosine 105. That's your first number. So it was negative 2.3. And then you would type in 9 sine 105. And that's 8.69, which we would round to 8.7. Okay, so remember, if you know how long it is, you know which way it's pointing, that's all you need, that you can break it down into the two parts. Okay? All right, but all that we did, like I said, was put the formula into the calculator, and that gives you your rounded values. Okay, so now take that, turn the page. We're going to work through one word problem, and then you guys can finish on your own. Okay? Out of the 2 word problems, we're going to work the second one. Okay, but you should be able to do either one. Okay? So first one, it says, we have an airplane traveling 550 miles per hour. That's the length. And then it says with a direction of south 25 west. Okay, so remember, you'll have a compass on your little review chart that you're going to get. Okay, but I'm going to draw that right here. Remember, it's north, south, east, west. And then remember that your cardinal directions are north is 90. West is halfway around the circle, which is 180. If I go another 90 degrees to south, that's 270. And then if I go all the way around the circle, that's 360. Okay. So remember, each of your directions has an angle that goes with it. So north is 90, 180 is west, 270 is south, and then east we'll just call 0 because remember, that's where you start from. Okay, so now let's break this down. It says south 25 west. Then you're going to start off pointing south. And then you're going to tilt 25 degrees towards the west. So that would be this way. So now think about, if all the way around to here is 270, what do I want to do with this 25 degrees? Do I want to add it to the 270 or do I want to subtract it? Okay, think about the question again. If I go all the way around to here, it's 270, but I only want to go all the way to here. I don't want to go all the way to 270. Am I going to add it or subtract it? Subtract it. Very good. So I'm going to say, okay, then my direction would be 270 minus 25, which is 245. Okay. So then I'm going to put my direction is 245. Okay, so now let's write the vector for the plane. We know the length, it's 550. So for my plane, it's gonna be 550 cosine 245, and then 550 sine 245. Okay, after we talk about the airplane, the next thing we need to talk about is the wind. Okay, look at what the wind's doing. The wind is blowing 40 miles per hour. That's how fast it's going. So I'm going to go ahead and set up wind equals 40 cosine, 40 sine. Okay, but then in those blanks, I need to put the direction. And that's where I'm going to read right here. This time it says south 45 degrees east. So set up your exact same little compass here. We know that south is 270 degrees, but this time I want to tilt to the east. And remember that the east would be this way. So that means I'm going to go 45 degrees this way. So think about if I'm already at 270 and I need to rotate 45 degrees past that, then I'm going to add those on to get the direction. Hey, Courtney. There you go.
Okay.
No. Okay, so your direction for this one would be 45 plus 270, which I'm going to do in the calculator. You can just move that card. Sorry. So it'd be 315. And then remember, what do I do with the direction? I pop it into the sine and the cosine in the component vector. Okay, so I'll put my 315 here and here. Okay, from there, you write your vectors separately. Okay, then your next step is that you're going to add them together. Remember, how do you add them? What's the rule when you're trying to add vectors? What do you add? X's with X's. You're going to do it in the calculator, and then you'll add Y's with Y's. Okay, so remember, you have to add the X's together, you have to add the Y's together. So let's do the X's first. I'm going to do 550 cosine 245 plus, and then 40 cosine 315. My first number comes out to be negative 204.15 is going to round to 2. And then I'm going to add my Y's together as well. So it'll be 550 sine 245 plus 40 sine 315. And then if it's 526.7, but the 7 has a 5 behind it, I'll round that to a 0.8. Okay, then remember, all of the work that you do is going to be with this combined vector. Okay, after you've added them, remember X's with X's, Y's with Y's. Okay, from there, we're going to find the same 3 steps, the magnitude. Remember, magnitude is a squared plus b squared, then take the square root. So it'd be 204 squared plus 526.8 squared, and then take the square root. Okay, and then remember, when you're in the word problems, you don't have to give the exact value because remember, we've already started rounding it. So 204.2 squared plus 526.8 squared, and then take the square root of that. So I got 564.99. That's going to round me up to 565. Okay, and then if you think about the plane's going 550 miles per hour, but then since the wind is also blowing south, it's actually speeding it up to 555. So the engine's working this hard, but then the wind is kind of helping it go even faster. All right, next 2 parts. Reference angle, remember that's tan theta equals y over x. But in this case, my y is the 526.8 and my x is the 204. And then remember to cross out the tan, you're gonna do inverse tan in the calculator. So it'll be inverse tan here and inverse tan here. So then I'll have second tan, 526.8 divided by 204.2. So I got 68.8 degrees. For all of your degrees, you're going to round it to the nearest whole number. So 68.8 is going to round up to 69 degrees. Okay, now remember, that's your reference angle. That's not the direction until you check the quadrant. Okay, so to check the quadrant, I got to see where this would be pointing. Okay, so look at your vector. If it's negative 204 and negative 526, then I would have to go negative 204 this way, negative 526 this way. What quadrant am I pointing in? 1, 2, 3, or 4? Both negatives. I went negative and then negative. What quadrant? 3. And then remember, we have put the formulas on the front. Okay, if I'm in quadrant 3, then it's 180 plus the theta. And so then in this case, if my theta was 69, I do 180 plus, and I get 245. All that makes sense? Okay. Last thing I'm going to say before you have the rest of class to work. I know some of y'all are opting out of this class for graduation. Okay, but if you're planning on passing this class, right now, all your grades are homework grades. So remember, quizzes and tests are worth a lot more. So if you don't do your review and you have 100 right now, you're going to have like a 40. And if you fail your test, it's going to go down even more. So remember, your homework's not a very big chunk. So if your grade looks good right now, awesome, but let's make sure that we get the big items done too, because they count. Okay, so your review is a quiz grade, and then you'll have your test on Friday. Okay. I will also post the answer key for the review today after school so that you can check it. So nobody should get a 0 on the review, and then you can use it. Okay. All right, you can do it. Show me your review when you're done, and I'll mark you off.